Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's the problem for today for exam P on probability. 4 letters to different insureds are prepared using along with accompanying envelopes. The letters are put into the envelopes randomly. Calculate the probability that at least one letter ends up in its accompanying envelope. And here's the solution. Let's begin with this more general question. Given m elements, how many permutations of those m elements move all elements, so do not keep any elements fixed in their place? Such permutations are called derangements. Let us write Pm for the set of all permutations of m elements, Dm for the set of derangements of the same elements, Ai for the set of permutations that leave the ith element fixed for I equal to 1, 2 through m, and then number of E for the number of elements of a finite set E. Then we have the number of Pm is m factorial. That's the number of permutations of m elements. You should know this for the test. It's very important. And then number of Ai, well, this ith element is fixed and everything else is moved all around, so that's as many as permutations of m minus 1 elements, so this is m minus 1 factorial. And then dm is equal to pm minus the union from I equal 1 to m of ai. And therefore, using the logic of the rules for the probability of a union, but applied to the count of elements of a union, we have this, that the number of dm, so the number of derangements, is the number of pm minus, and it's this probability of the union, and that's the sum from I equal 1 to m of number of ai. Normally we would subtract, but we're subtracting the probability of the union, so minus minus, that's a plus of the probabilities of ai1 intersection ai2. Next one will be minus, and so on up to negative 1 to the power m times the number of a1 intersection a2 intersection am. And that's m factorial minus m minus 1, m choose 1 times m minus 1 factorial plus m choose 2 times m minus 2 factorial, so on up to negative 1 to the nth times m choose m times 1 factorial. That is equal to m factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial, and so on, minus and up to negative 1 to the mth times 1 over m factorial. For m equal to 4, the number of derangements is therefore 4 factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial, and the total number of permutations of 4 elements is 4 factorial, and the probability sought is 1 minus the ratio of those two, so number of derangements divided by the total number of permutations, because what's subtracted is the probability that we have derangements, and what we're looking for is all rearrangements which are not derangements. So in this case, this becomes 1 minus 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial. That's equal to 1 minus 1 half plus 1 sixth minus 1 over 24. That's equal to 15 over 24 of 5/8. That's answer D. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.